Hello everyone, so in this video let us talk about the first 4 problems from the AtCoder beginner contest 283. So let's start. I'll also make a video for the 5th problem, so stay tuned on this particular channel. The first problem is power. It's pretty much simple. It states that you are given two integers a and b and you have to print the value of a to the power of b. So it's pretty much simple. You can solve it in very different manners. You can use the power function provided by different you can say different languages, or you can multiply a b times. So if it is a to power b, you can multiply a, okay, sorry, a b times. That's it, like any of the possible ways you can use. So the solution for this is pretty much simple. I'll show you the solution part of it. It's I've used the power function provided by c++ a to the power of b. The second problem is that you are given an integer n and a sequence a of n numbers, as you can see, of length n. Now you're also given q queries. In each query, you are given that what you actually have to do. So there are actually two types of queries. What you can see here is the query of type 1 provides you two values, that is k and x, and you have to set the value of a k to x. So the kth value in the array A, you have to set it to x, and k is, as you can see, in 1th index, not 0 index. And because as you can see that k goes from 1 till n, and the other type of query is that for any particular k, you have to print out a k. Okay, so it's pretty much simple because this operation can be done in O of 1, because you just have to set that particular value to x, and this is just printing out that value. So all of them can be done in O of 1 time only, and their q queries. Q is 10 to the power 5, so you can directly easily run them. So it's pretty much simple. You can just input all the numbers inside an array of length n, then iterate over each query one by one, and then according to the query, perform this particular operation. So nothing much complicated here as well. Let's move on to the code part now. So what we have done is that we have taken in the input of all the numbers, as you can see here, then take the input of the queue, what number of queries we have. Now for each query, we have to first determine whether it is of type 1 operation or type 2 operation. So first take the input of operation 1 or type operation 2. If it is operation 1, then take the input of two more values, k and x, and then in a of k minus 1, because k is of 1th index, set that value to x. If it is operation 2, which means that you have to just print out the value, then take the value and print it out. Okay, pretty much simple, nothing much complicated here as well. Moving on to the third problem. The third problem is that Takahashi is a cashier. Now that particular cashier has a cash register which has 11 keys. The 11 keys are 00, then 0, 1, 2, 3 till 9. Now if the cash register displays 0, so initially the cash register displays 0, and then whenever he types the key 00, whenever he types this key, so you can just assume that there's some cash register, okay, like this, and it has different keys, and the keys are this that is given to you. Now initially the cash register, let's say, show 0. Okay, now whenever he types the key 00, the display number is multiplied with 100. So whatever is the displayed number, let's say the displayed number is, let's say, 5. If we press 00, it will be 500. Okay, and whenever he types any other digit, the display number is multiplied by 10, and then the added number is added to the key, which means that, let's say, the display digit is 5, I press, let's say, 7, so 7 is appended to the next number in whatever number I have. So in simple terms, it has 5, it multiply it with 10, it becomes 50, it adds 7, it becomes 57. So in simple terms, whatever number you press apart from 00, it is added to the right side of the number that is currently displayed. If it is if it is some odd number, like if you press 00, it will just multiply it with 100. Okay, now Takahashi is a cash register and you want to display S as an integer on the particular cash register. Now what is the minimum number of keystrokes you have to press to get S? That's the whole thing. Now it's pretty much simple also, you can understand it. Let's take some example to understand this whole thing. Let's take this example only, that is 4, 3 zeros and 4. Now whatever number you are pressing apart from, let's say, 0, 0, like every number is appending towards the right side. So why not just iterate from right to left? Okay, if you find out any number, let's say I find out 4, which means that if I somehow got to 4,000, I can just press one time 4, it will be appended. So this is one keystroke. Now, if I have two consecutive zeros, why not just press the two consecutive zeros? One, because let's say if I have 40, I can directly just press two consecutive zeros. It will be 4, 3 zeros. So it's pretty much simple now. I hope you understand the point. I also have 0 also in this case. So I have also 0. So if I just want only one 0, which means that let's say if I just want 40, I can just press I can first press 4, then I can press 0, I can get 40. Okay, that's the logic that we have to use here. So what you can do is that in simple terms, just iterate over this whole string from back to front, that is from right to left. And then whenever you find out a number, just increment that. I have to press a key to get that number. If I get two consecutive zeros, then I have to just press one keystroke to get this particular thing. If I have only 1 0, then I have to press one keystroke or 4 for one keystroke. So for this example, I have to press one keystroke, one keystroke, one keystroke, one keystroke. So total of 4 keystrokes we have to require to get this particular number. That's it. That's all the logic for this particular problem. Nothing much complicated here as well. So let's move on to the code part now. So what we have done is that we have taken the input of the string, then the total of keystrokes that we have to do, then iterate from back to front, that is from n-1 to first number, then check that whether the number I am on is not 0. If it is not 0, we have to press anyway a keystroke, so total increment will be 1. If it is a 0, if it is not 0, we have taken case, which means that it is a 0. If the number I am on 0, then we have to check that the number just to the left of it, if it is also 0 or not. If the number to the left of it, first we have to check that it should exist. So if the number I minus 1 is greater than 0, which means that that particular number exists, and that is also 0, which means the current number I am on is 0. The next number on the left hand side is also 0, which means that I just have to press one keystroke, that is 0,00, to get this particular two consecutive zeros. In that scenario, we will increment my total by just one number and also just skip the previous number. Let's say that I have 4,000. So when I come to this 0, I will check that the previous number is also 0. Yes, they both are 0. So in that scenario, I have taken this as a complete number, and now my pointer should go to this point. So I minus minus will come from here, and one I minus minus will come from this particular for loop as well. So there are two I minus minus, so that I will jump two places. So one place and two places. Okay, so that's why we have used this. Else, if there is only 1 0, the left hand side of it is not 0. Let's say it is 404. I found out 1 0, but the left side of it is not a 0. So I just have to press individually 1 0 to get this particular keystroke, you can say digit. So yeah, so total is increment by 1. So it's pretty much simple. Whenever I find out two consecutive zeros, that should be counted as 1. Apart from everything else, we have to just take it as another keystroke. In the end, we just print out the total number of keystrokes we have done, and that's pretty much it for the particular problem. Let's move on to the fourth problem. The fourth problem is good. Okay, the problem statement goes like this: that a string consists of lowercase English letters, open bracket and close bracket. So it consists of three type of things: English characters, lowercase, upper like open bracket and close bracket, and it is said to be a good string. A string is called good string if it follows this particular conditions, which states that you can first remove all the English letters out of it and then repeatedly remove all the consecutives, open and close brackets. So if after performing all of this operation, if the string becomes empty, then it is called a good string. Okay, what it eventually means is that let's say that we have this particular string. First we have to remove out all the, let's say, characters out of it, so it will become like this. Now I can easily just take out pairs out of it, that is, let's say this open close, and just try to remove all of them to make it an empty string. If I'm able to do that, then that is a good string. Okay, now the overall problem statement boils down to this: that you are given a string S. Now Takahashi has to perform some particular operations in a particular order moving over this particular string. So you're given a string S, let's say, and which consists of the same amount of thing, A, B till Z, all the lowercase, and open brackets and close brackets. Now for each lowercase English letter from this, we have a ball with a letter written on it. So let's say that this string, you can assume that there is A and B. These are some balls. Okay. Now what you are actually doing here is that for each I moving from left to right, for each I over the string moving from left to right, Takahashi performs some falling operation until he faints. So he will keep on performing the falling operation until he faints. Now the operation is that if in the given string, if the S of I, the ith character in the given string, is lowercase English letter, Takahashi will put the ball of that particular character inside the box. And if the box doesn't contain that string previously, like not string, the particular character previously, then it is okay. If that particular box already contained that particular character, then Takahashi will faint. Don't worry, I'll explain you in more simple terms. Just stay with me. If the S of I is open brackets, then you'll do nothing. If it is a close bracket, then you will take the maximum integer j less than I, such that I to j, the substring S, is a good string. Okay, and then what you'll do is you will take out all the balls between I and j, that is a good string, and from the box itself, and you will have to keep on doing this operation. And if you have to just tell that whether Takashi will be able to do that operation over this whole string, else he will faint. Okay, don't worry, I'll tell you with the very two examples. This will be clear to you. So I will take this example as well as this example. Okay, let's talk about this example first. The example is that I have open A close B A close. Now, in simple terms, what you'll do is that Takashi will iterate over this whole string from left to right. Okay. Whenever he see an open bracket, he will do nothing. Whenever he see a character, an A or B, you can assume that there's a box. He will put that particular character. You can see that there's a boxes or ball, like this particular character or ball. Put it inside this box. So let's just move around from this string from left to right. Open bracket, leave it. Open bracket, leave it. A, okay, put it inside the box. Now, whenever he see a closed bracket, his main thought is that I have to somehow make a good string ending at this point. So I have to make a good string that is, this is I and j. So which means that this is a good string that is starting from some point, let's say I, and ending at this j. And whatever is a character in between that good string, that should be removed from the box. Now, I've told you that it is a good string in what scenario? I will take a string, remove all the characters in between of it, and it should be a, you can say, proper open bracket, close bracket type of string. So if I've taken this string as the close bracket, and I only have one open bracket, like you can, sorry, close bracket. So if it should be a good string, then I will close it with only one open bracket. So which means that whatever is the closest left side open bracket, all the characters between that should be taken out from the box. Okay, it might be a little bit confusing, but it will become more clear as we talk about problem statement. What you can see is that I have to iterate over from this open bracket towards the first open, sorry, this is the closed bracket. So I have to first find out the first open bracket to the left side of this closed bracket. So I just iterate over that and find out this. So all the characters between them should be removed from this box. And there is only one character, this A. So A should be removed. So A should be removed. Now iterate over this whole string again from right to left, sorry, left to right. I'll find out B, B put in the bracket, A put in the bracket. Now I'll find out one more closing bracket. So I will find out again the closest opening bracket in this whole string. I've taken this already, so I'll take this. All the characters between them are removed from the, you can say, from this box, and okay, I'm good to go, because Takahashi will only faint if when putting, you can say, a character inside the box, that character already exists. In this case, because we have removed this A in this iteration, I can easily send B and A again. Let's take the next example. In this example, if I have open A, open B, A, close, close, when I'm iterating from left to right, open just remove, just left. There's a A, so put it inside the box. Open just remove. B, put it inside the box. A. So I again find out A. And I am not being able in the case in which I have removed these A. So which means that whenever I've tried to put one more same character inside the box, and we have not removed the previous ones, then in that scenario, Takashi will fail and the answer is no. Okay, that's the whole thing. Now, let's move on to the code part and the actual solution part, how we'll solve this particular problem, because it might seem a little bit difficult, but it's not. Because the thing is that whenever I want to somewhat pair brackets, the one data structure which comes to mind is stack. Let's use stack here. So the overall idea is that whenever I find out an open bracket, just leave it. Whenever I find out a character that is A, I have to put it inside the box. Let's take it as a set, because set only stores unique characters. And that's I also wanted. I just want a unique characters. If the same character appear again, then that is bad. So for the box, I'll use a set. For this whole string, I'll use a stack. Now what we'll do, return from left to right of this string. If I find out an open bracket, I will put it inside the stack. Okay, I'll find out an open bracket, then I find out a, then I find out again an open bracket, I find out B. And whenever I find out characters, I will keep on inserting inside the set. If I again find out that I want to insert A, then the whole problem will be solved, and it is like it is bad string. Let's take the previous string again and use this example. Let's say that we have a stack, we have a set, and what we'll do next is that we'll iterate from this string. I find out the opening bracket, again open bracket. I find out A, so A put it inside the stack and in the set as well. I find out the closing bracket. Now, when I find out the closing bracket, what I'll eventually have to find out is I have to find out a good string. I have to remove it from all the characters between this string and the previous occurrence of the opening bracket. So this is the closing bracket. So I will now keep popping out elements from the stack until I find out, you can say, an opening bracket. And all the characters in this procedure will be removed from the set as well. I hope you get the point. And that's it. I just have to keep on popping out element. If I find out A, I'll remove it from the set as well, because it's very fast operation. Now, if I find out any other characters, whenever I find out an opening bracket, I will stop at this particular point, and which means that this is completely done. I have removed out all the characters in between this good string also from the set, and I will keep moving forward. Now, I don't have, let's say, A. I will insert B in the set as well as in the stack, A in the stack and the set, because there is no already A. And then in the end, I again find out closing bracket, and I will do the operation remove it as well. But the problem in inserting is solved. Okay, because I will don't have to insert the same character again, because it is already proved. Okay, that's the logic that you have to use to solve this particular problem out. Let's move on to the code part now, so that you can easily understand more what I have talked about. So what we have done is that we have the string itself here, okay, and the stack and the set in which I will store out these alphabets or the balls, you can say. Iterate over this particular string, okay, and then see what all operations we have to do. Okay, this is how the for loop will start. If I am on an opening bracket, then I will insert that opening bracket inside the stack. If I have on a closing bracket, then what I'll do, I'll do something I'll tell you later. Just wait for a second. And if it is not an opening bracket and not a closing bracket, it is an alphabet, then what I'll do, I have to first check that the alphabet I am inserting inside the set, it is not repeating. If it is already repeating, which means that the frequency of it is not 0, then which means that I'm inserting a character that is already inserted. So in that case, I will like output no, that this is not a good string. Not a good string, that this is not a valid operation. And like Takashi will faint, answer is no, and return this out of this particular program. Else, I will take that character, push it inside this, you can say, set, as well as inside the stack. So both of them are inserted. Okay. Now, the other case is that if it is an opening, I will insert the opening inside the stack. If it is a closing, in that scenario, what I'll do is that I will do a while loop over the stack and keep popping out elements until I find out a opening bracket. If I find the opening bracket, I will just stop from the stack until, unless what I'll do is I will take popping out elements from the stack, and if it is, you can say, a character, I will erase it from the, you can say, set, and the set is this. Okay, that's it. These are the different operations that you have to do. And the end, if this whole operation completely processed, I will iterate over the whole string, nothing hit this statement, then the answer is true. That is yes in the end. That's it. That's not the logic in the code part for this particular problem as well. I'll just iterate over this whole code again. I will also put that particular code link in the description of this particular video. You can go and check this out as well. And that's all the logic in the code part for this particular video as well. If you still have any doubts, you can mention in the comment box for this particular video. I will see you in the next one. Keep coding and bye.